So thank you very much for joining us today. Now that my microphone's all set, I think we're good to go. My name's Tom. Today we're gonna dive into the oldie CAD days, do a little bit of medieval storyline. And when I say simple, I mean my models are real simple. So I'm not asking you to critique my models, but let's focus on the intent and the methodology behind them. Now, hopefully this gives you some useful, and maybe we're gonna have a couple laughs along the way, ways that you can use motion analysis in your SolidWorks assemblies. Not only the motion itself, but also you can glean some pretty cool data out of this. I'm going to show you a couple of those ways. One thing I do want to say, this is not going to cover the whole anthology that motion is. There's a lot that you can do with it, a lot more than I'm going to cover today. And if you have questions, come see me after, and I probably won't be able to answer them for you, but I'll be glad to dig into it and get back to you at another time. So just a little bit about myself. I studied computer-aided engineering, not right here at GRCC, but at the downtown Grand Rapids GRCC campus. So GRCC is a little bit of my alma mater. So that means if I do terrible today, you can go to that office right down the hall and let them know they did a terrible job with their mechanical design and engineering program. After that, transferred to GVSU for mechanical engineering. I've been using SolidWorks since. Across many industries. I've been, office furniture is huge around here, of course, automation, sporting goods. You've seen some of my stuff if you watched the Summer Olympics, and I've done a little bit for the Department of Defense here and there as well. And for the last 18 months, I shifted my career focus to work for Swift as a VAR. I'm on the tech support team, which has exposed me to so much SolidWorks. So much SolidWorks. I had no idea that I didn't know so much about SolidWorks. And motion studies is one that I had dabbled in, but I hadn't really gotten a chance to really get into it deep. So we're gonna go a little bit of a deep dive there. Now, I don't see any repeat faces today, but if you did happen to come last year, I did go over a few topics I think that are kind of important leading up to motion analysis. And I just wanted to go over these real quick. I'm not gonna do a full deep dive of last year's presentation, but a few important things are advanced mates and flexible sub-assemblies. And these are things you may know already. It's okay, take a nap. I will not be offended, but we'll get through these pretty quick. Okay, so welcome to Swift Keep. This has been a little bit of an inception of mine since, I guess, March or so, where I wanted to showcase some of these limit mates and how you can, I guess, leverage them without getting into really complicated models and robots and kinematics. So I thought, hey, medieval trope is a great way to do this. And let's go ahead and look first at limit mates. So how can we let our knight into our castle? I did pre-record all these. I'll skip through some of the boring stuff. But you see, anytime you've set up a couple of mates in SolidWorks, not necessarily gonna behave like it would in real life. That portcullis or fence is going right through everything, unlike it would in real life. So if you know the distance that you think that should move, let's say you happen to know there's a 120-inch gap within that wall somewhere, we can use simple planes to define distance from, something to something else. But then it's going to want to move to that, as you just saw here. But if you go to your advanced mates, and if you haven't looked at your advanced mates before, I highly recommend checking them out and taking time, setting time aside to study all the things that your advanced mates can do, because they're super powerful. Now we go into that advanced, and just by choosing that icon there, it opens up a whole set of options for different sizes of that mate that you just saw me dragging that portcullis around. We're going to go ahead and, we know 120 is going to work from rehearsal. Set the other value to 0. And this should, if I recall, drag it down. You see the mouse keeps moving, but the portcullis has stopped. And that is representing a much more realistic range of motion, something you might expect in real life without having to set up motion studies. And the cool thing, though, is that we can use that later on once we do get to our motion studies. Now, let's open up doors with realistic mates. And you see I shifted my, my color scheme there. I forgot I had left it on dark for that video. This is, I'm sure all of us have downloaded hinges from one of our favorite manufacturer supply websites, and you take this part and put it together, make an assembly, maybe get your barrels lined up, get your concentric mate, but it goes all the way around. And hinges in life don't usually go all the way around. They're usually like 270. Maybe they'll have some kind of interference with themselves at 120. So we can use a rotational limit mate to mimic that right here live in your SolidWorks viewport. Again, much like we did with the distance mate in a linear way, this is in a rotational way. So we have a door. I'm just going to pick a couple faces, show you how it's not operating how I want it to. Looks like my cropping may be a little bit off, and I apologize. That in PowerPoint is not my forte. But if we go in and we mate this guy right here, go to our advanced mates ahead of time this time instead of switching it later, you'll see I'm going to go ahead and define this the way I want it, 0 and 90 degrees, just because that's as far as I want the door to open. Not necessarily because I have done the dragging and the interference detection, which you can do to find this distance, but I wanted to show what happens when it solves the wrong way, because SolidWorks does let you flip it, just like you do any other mate in SolidWorks. So that's, you flip the mate around, confirm the mate, and get out of mates. And lo and behold, it's operating pretty much the way we would expect. Now let's go ahead and see where this one's going. Let's check out some gear mates in a winch. This actually got me in trouble with ye olde OSHA, and you'll see why in just a moment. But my little guard up here has a winch that he wants to use instead of trying to hire an ogre to lift a heavy portcullis. Now, you can actually assign gear mates in SolidWorks too. I've, again, very much simplified these models. I've just used circles instead of meshed teeth. But if you think of the diameter of those circles as your median of your gears, where your teeth would actually intersect with one another, this can give you some pretty realistic results. You do have to know a little bit about how gears work, what that mean diameter would be, and assign it that way. However, since I just used circles, it already picked those values out for me. So it's going to go ahead and assign that, and for every, it ended up being almost a 2-to-1 ratio, you know, of turning the crank, and we'll turn the shaft as well. Okay, so these, whoops, I can't click on that screen. This guy right here. So I'm just highlighting those. I didn't actually change them. They are pre-populated with the diameter of the circle. If you wanted to change that gear ratio, because you know the math, otherwise you certainly can. You also can reverse that if you're using a belt, because gears will turn counterintuitive, but belts will follow each other. There's an ability to reverse that too.
Diameter of the circles rotating into the circle that's getting affected by the other.
Exactly. Okay, now we're actually going to have the guard crank the winch. And this is my last little point in my recap, and this has to do with the flexible sub-assemblies. And you'll see this, see me stumble my way through this as we go back to the main assembly after having fixed all those little gear mates inside our winch assembly. It's not moving. Anybody know why it's not moving? You need to make the sub-assembly flexible. This is kind of a fun little, I'm looking through here trying to figure out what's wrong. That mate right there cannot solve to my guard's hand, which is a very crude model, I know, but it's all going to work together in just a moment. So once I finally remembered that that's why it doesn't work, we got to go back and switch that to flexible. And go back and pause that just for a second. This icon right here, that's a flexible sub-assembly. So if you have a fully defined sub-assembly that you bring into another assembly, this isn't going to make any bit of difference. You can click that all day long, drag things around, still not going to work. If you, however, have left any degrees of freedom available, then when you make a sub-assembly flexible, bring it into another assembly, that little icon right there is the key. Matt would say, I think, press S, which is your search, and type in flexible, and it will give you the option for the flexible sub-assembly. So that's one I can also demo after the presentation if you'd like. So here we go back to actually setting this to flexible. Something's still wrong because it's mated to something else that's not flexible. Now I've got both of those sub-assemblies set as flexible, and we'll see as I start to turn that crank, it should find a solution. And now we've got not really an animation, but an actual live in your SolidWorks viewport kinematics study of a knight or guard raising the gate. Now we'll go ahead and hide our castle walls. That took one last step, and that's a rack and pinion mate. So I wanted to show that. I didn't need to get into it in super depth. It's much like a linear gear arrangement, much like you'd find in your car. You find it a few other places, especially if you're using robotics. This can simulate that very much the same as two gears working together. So now we've got flexible assembly there, or sub-assembly there, flexible sub-assembly for the guard, our rack and pinion mate, and by golly, that guy is just going to town cranking up that gate. But you can actually, if you have your gear ratios right, you can actually see how many cranks is it going to take to raise that portcullis 120 inches. And it works in reverse too. So if I grab, okay, our night is in, if I grab that portcullis, pull it down, and I see our guard also has a terrible backache from this and has gotten me in trouble so many times. Every time I give this presentation, I have to go to a safety in the ye olde workplace presentation. Now, everyone here is welcome. I don't care if you're a SolidWorks user, if you started SolidWorks yesterday, if you've used SolidWorks 20 years, or if you use AutoCAD. It's okay. We want you in here. I will say that kind of was my thought at first. Like, okay, why is our knight trying to get in? What's the story behind all this? He must be yet running away from ye olde CAD desk armies. We don't want to be caught by them, do we? But that's not fair of me to say. It's a great product. I'm not going to say anything bad about it. I started on AutoCAD. I don't want to tell you how long ago. So today, I'd rather say our knight is trying to get to a medieval Renaissance fair. All are welcome. I don't care your CAD platform preference. I'm not trying to flex, but I am trying to say let's all work together. Let's all come together in this world of CAD and make some cool stuff, right? So let's go ahead and take a look at some motion at this fair. All right, now that we know how to move our model with realistic motion, how can we animate it? I'd like you to meet your host, Jester Tom, that I threw in the slide a little bit too soon on this last one. He comes with snarky comments. He'll throw in a dad joke. You can completely ignore him up in the corner. But before I get going on that motion analysis, he's right, a couple of provisos. This is only available on Professional, Premium, and Ultimate level of SolidWorks. If you need help convincing somebody else that is paying the check for your SolidWorks, this is a great argument. I can think of several times where I have shopped out my video presentations to another company. They've rendered them up for me, sent it back. I wrote an email, made changes, they rendered it, got a big old bill at the end of it, and everything worked out fine. But shoot, 2 of those videos would have paid for the upgrade from standard to professional. So just something to keep in your back pocket when you leave here. If you don't have access to this, I don't make a dime on it. We aren't trying to sell you anything. We just want you to have the right product for the right tools for what you're trying to do. Now, what are we going to see in this motion study presentation? A little bit of gravity, creating some views, creating that video, right? The animation is huge. Going to get into rotation and maybe another neat little application of gravity that hopefully nobody gets motion sick. I'm just kidding. They'll have some complex interactions. Think like that 1970s mousetrap game, only I've made it a lot easier. Force application and some reporting will be part of that. And don't worry, even if you are on standard, you don't have motion analysis or animation capabilities today, still got something for you at the end of the video. Now, let's go ahead and show you. This is an animation that I threw together in SolidWorks in maybe 20 minutes. I'm going over our gravity demonstration, our rotation demonstration. We're going to swing back around. There's my Rube Goldberg complex interaction. And you can't have a medieval fair without a jousting contest. So we're going to take that and inspect what that might look like when those two jousters collide. Now, I'm not going to do this for every slide, but I did want to go through setups. If you do have SolidWorks Professional Hire, you do need to turn on this motion add-in. I don't believe it's on by default. Even if it is, you might have turned it off because it takes a while to load. Just in case, go to your tools, add-ins, make sure it's enabled. Now, we'll get into this a little bit more, but please don't forget to add gravity. That's what makes a motion study realistic. If you're only doing an animation, you don't need this step, but it took me a while to find the little apple, especially if you're looking around online and you maybe have seen some older videos and that's a red apple in the video and you're looking for a red button somewhere on your motion screen, it's gray now. This is 2025, so okay, and the next step, we're going to assign contact sets, because if you have things moving around with one another, you want to make sure if one thing hits another thing, that there's actually some kind of contact resolution, that you know that it's going to move as you would anticipate when it collides with something else. And finally, we're going to show how to add some views, and we are going to save the video. I think I have that in there. No, I don't, but we are. I'll show you how to save that video out. There we go. Calculate and save. Now, we have gravity, and that's going to be our biggest thing that we focus on right here. But we've got our little Plinko board. This is ye olde Plinko. This must have come before they've ever saw any of those Price is Correct? Is that how it goes? Before they ever saw that game show. Very similar idea though. I'll go ahead and I set this up in this video. There we go. Okay. Clicking on the motion study tab right down here at the bottom of your screen. Once you've activated the add-on, that's where you'll be able to find that. And you see, this is actually pretty easy to set up. I have two views and it's rotating between it for me. But if you saw that, I'll go back just a little bit. If you saw that, we're bouncing around. Watch the puck as it comes down. It's bouncing around pretty bad. Now that was just very simply adding gravity and hitting play. That's all I had to do to get it to this point, but it's not very accurate. So if we go to our settings, up here under our properties, we have frames per second, 3D contact resolution. Those are going to be huge, important settings. Yes, the higher you make it, the longer it's going to take to solve. But now that that's all I've changed, I didn't change anything else. So we see that we actually have a different path that the puck is following. And it's taking a little bit longer as it's resolving each one of those contacts with all of those points instead of skipping over a bunch of pegs. And you see, I made the video just a wee bit longer. I should make it all the way to the bottom this time. There we go. Still, something's not quite right. It's kind of staying hung up against that back plate. Don't think it would do that in real life, especially not since those pucks have those little chamfered edges. So let's show. Okay, I'm adding a view there. I don't like the way that it rotated right off the bat. So I'm adding a little bit of a gap before the rotation starts. And now that's just by right-clicking in that area and placing a key. Now, I think this comes from video editing terminology. Keys just means an action happens at that point. And then I'm going into my mates. I'm going to turn that coincident mate off. And that's what's going to allow that puck to kind of fall, and hopefully it'll fall over much more like it would in real life. And that's kind of the aim of these basic motion. It's the aim of your motion analysis. It's more than an animation. You want to see it do some really similar to real life stuff, falling, hitting the pegs, and flopping over exactly like you'd expect. So that's, I think, the most basic motion study that you can possibly put together, is just one piece interacting with another and applying gravity. Now, what if you wanted to have more than one puck? Can we do that? Can it solve that for us? Absolutely. Now we're going to start in the same vein, only I made another configuration. We have several pucks up here at the top. It's a little washed out on this screen, but you can see them up there at the top. I'm going to roll my screen back to the start, or my video back to start. And anytime you want to drag that bar around, that vertical blue line really helps you know, and it indexes with any keys that you may have had, so you can see exactly what you're doing. Now, I just moved that manually. I didn't have any mates assigned to it. I didn't have to get out of the motion study. I just moved it, and it remembers where it's at. And I'm going to make the same change to that orientation view that I did before. Okay, and we had some issues with our pucks kind of not interacting with the board. That's because I didn't set my contact set. That is fine, just like editing a feature on your feature tree. You can right click on it down here, or it's this button right here. They do kind of try to keep everything confined to you in the bottom left corner of that motion view pane. And now I've got all of those selected, and you'll see if I up my, here we go, up my resolution, these should go off well if I remember correctly. Now recalculate, and that's going to be, that recalculate button is going to be your best friend. I promise you that. Looks like they're all going pretty well, but once again, they're all leaning up against the wall like I didn't like before. I don't think this is a very realistic study of what would happen if we were to have a 5-player Plinko game. So let's go ahead, and I actually go through suppressing all of those other mates. And that, you don't need to watch me do every single one of those. But what I'm doing is right-clicking within the mate for each part in its own timeline bar and hitting that right mouse button and suppressing. Adds the key. I guess we'll go ahead and watch all of them.
Now they'll all fall the same, right? Every single time.
If they all start from the same place, yes. But if you change like your resolution, that can change the results. Now those 3 that went down the side, they stacked up with one another. Those 2 had a collision and flopped down exactly like you'd expect them to do in real life. So this gets us real close, I think, to what we would see in a fair situation. You got 5 people playing, you have them all go at the same time, they all go down. Now this is kind of just a fun, silly way, but for me to animate what I think would be a good example of gravity in real life. Go ahead.
Does your motion study portray a degree of randomness, or is it perfectly repeatable exactly the same way every time?
If you don't make any changes, it is perfectly repeatable the same way every time. But if you change the position of your puck, if you can change the gravity. If you want to try this on Mars, you can change that constant. And the one that surprises people, as I mentioned, is the resolution. So if you think about a circle interacting with another circle, as you change that resolution, you get more and more facets. And those facets might hit at slightly different angles. That can change the results.
Now, is there any possible way you could add in another motion, like having the 5 pucks slide back and forth so that when you start the motion, they'll drop in a different position of the car? Like incrementing another motion so that it is more random?
That I don't know. I'm inclined to say not with this. Oh, you could add a force, but I don't think it would be random. If you're looking for a random results predictor, I don't think we could take this to Vegas with us, unfortunately. But we could add a force shift. Yeah, I know that's how SolidWorks got to start. But anyway, you could shift them all over with a force, and then that would create one different set of results, but not random each time. All right, now we're going to move on to our Ferris wheel. And so dragging things around, you saw me move the puck before. Dragging things around is not the only way to move things in motion analysis. I'm going to dive right into it here. I'm going to go right to our Ferris wheel. And in this case, there's actually more things that I can add. I want to point them out when I pull this up, but right now it's locked. It's not going to do anything. Just like making a sub-assembly flexible that's fully defined isn't going to do anything. So right off the bat, I just suppress that mate so that when I go in my motion study, it'll run as expected. And just like your drawings down here, right click, you can make another tab for another motion analysis. And I don't know if you saw that. I didn't see it. But anyway, let me get right. There are several buttons down here for applying types of motion. So we do have rotational, spring, damper, force, cam follower, and gravity. So you can actually get really complicated with this beyond what I'm going to cover today. Just know that they exist if it might happen to fit your situation better. Okay, now after we've applied that rotary motor to the central shaft, not that difficult to conceptualize. You apply a speed. I started at 100. That was way too fast. We went down to 10, and looks like it might be kind of a fun ride for everybody. Now, I'm just watching my time just a little bit. So I am adding in those keys to update the views again. I think this is probably one of the cooler things the software can do, because you can find a lot of things out there that will simulate the motion for you, but to throw that in with rotating around from one view in a smooth blend for you, there's photo edit or rendering software out there by a particular kitchen appliance name that doesn't handle it as well as this. So now we're getting into our save, which is just clicking this button right here. You give it your values. You do have some options in terms of frame rate and what you put out. It will, what format you put out. It will recalculate, and then it is saved to your hard drive, whatever path you defined. Okay, now our little gesture's saying, oh, I don't feel so good. And this is adding a center of gravity, and this is still kind of dealing with rotation. So I decided to go ahead and put that right into the Ferris wheel presentation portion of this as well. If you haven't used the center of gravity feature in any of your SolidWorks models, whether it's an assembly or a part, it's kind of nice. It's kind of handy if you just click on this and you say, give me a center of gravity, and it shows a black and white datum right where that lives. Left, right, front, back, whatever. You can always find your center of gravity. So in this case, we had a model with a center of gravity that's a little bit off-centered, and you're going to see what happens. And then we will recenter the pivot point about that center of gravity. And if I did it right, we won't see any results at all. So this will be one of the few times that I have no results as a good result. Okay, so we've got our rider in our Ferris wheel, and this is just a homogeneous material applied to the mannequin. It's not like a human body. It's very rough. I'm not actually trying to find center of gravity, but that was just as far as going into reference geometry and picking that center of mass. And it shows you very, very clearly right where that's at. And I can see that my pivot isn't on center. Well, let's go ahead and see what happens. That's not that big a deal, right? Now, keep in mind, this is another motion study. This will be another one where I have gravity applied. I have not added any friction or anything like that. So we're just going to let this guy go. And no, oh, I did want to highlight this is the basic motion as opposed to just animation. I will say it doesn't look too bad as it's calculating, but when I replay this video back afterwards, my wife doesn't like this. However, I can't play Rocket League around her either. So here we go. Let's give this a quick play from here. Now we're seeing how that center of gravity being off from the pivot point could possibly affect the riders. This is fine for us thrill seekers and it's us hockey players and mountain bikers, but maybe not so much for those who don't enjoy the rocking motion. So a real quick edit here, and all I'm going to do is go ahead and drag that face right onto my center of mass. It grabs it just like a sketch point. So anytime you have anything that's any sketch plane that can see that center of mass, it'll grab it. So we're good to go. It's all centered. Roll back to the other screen. Spoiler alert, nothing's going to happen. Recalculate, and it just stays perfectly where it is, because if nothing's acted upon by an outside force, what happens? Nothing. So that's one of those cases where when nothing happening is a good thing. Now, complex interactions, chain reactions, and if like anybody remember the 70s mousetrap game? Awesome. You're too young to know that. You guys are too young to know that too. That's cool. I like seeing that. I'm glad that there are still some analog things out there that translate. So we're going to look at that a little bit. In this game, we have a ye olde ball of rock. I think I actually assigned it as lead so that it would have a large mass. What we're going to do is going to drop it on that diving board for that last bit of the game where the diver goes into the cup. But we have to set some things up properly. Now what this is going to do is going to translate that gravitational force. Then you have that impact, and as long as you have your settings right, it should move the diving board, and he should jump or go flying, as I put it in here. Let's watch this video. There we go. I tried to do some fancy camera work there, but basically I'm just opening up or I called it a teeter-totter for fear of copyright infringement. And we have, let's see, unsuppress that. That is my lead ball. That's going to interact with that diving board. Diver should go into the water. Have a nice little pool for him to land in. It's not going to hurt too much, right? All right. What was that? Unless he doesn't hit the water, you'll see what happens. I just want to make sure that I have defined all these things in the context set, just like I did previously. These are rather important too, because if you don't have them all assigned properly, you might have the diving board move, but the diver stays static. Not what we want in a motion study. So we'll go ahead and confirm that. Make sure gravity is applied. Otherwise, things get, well, they don't really do much because the mannequin just kind of falls over. And we'll go ahead and give that a bump up. We'll get into this precise control in the next one, but that is an option too if you really need to get some really fine control here. And I don't know if y'all have ever seen $1 Million Baby, but I think that guy's not walking ever again. But what actually happened? It's kind of hard to see because I did a little bit of math, and based on the force, why I made that rock really heavy, he should have made it. That should have been okay. Something set his trajectory off. I didn't really capture it super well in the video, but his toes catch right on that lip of the diving board. Now I put that in there so he wouldn't slide off in the start of the video. You can constrain that in other ways or turn off mates in other ways. But here, I just wanted to have that lip and edit it. I'm editing it right in the motion analysis. I didn't have to get out to the part. I have my instant 3D on, so I could just drag that face down, staying right in the motion analysis functionality. Didn't have to get out of it at all. Our diver makes it in the water, and he's right back out again. It's one of my favorite moments, probably of 2025. Is the first time I ran that. Now you can make that more accurate, adding dampers, or I'm not sure on this one. I think you can add friction as they enter the water, so it'd be a different, like viscosity almost, although it's a different mechanic, but you can emulate it. That would be more of a video simulation than an actual motion analysis, but there are things you can do to make it better. Now, point number 4, refine interactions and inspect results. This kind of going back to what I was saying before, that I keep forgetting to hit play. There we go. Now we are in the motion analysis category now, and that comes with SolidWorks Premium. Not professional, but when you have that, you can start looking into those forces. You can start getting some of these feedbacks from all the time you set into your motion mates and your motion analyses thereafter. So as long as we have everything set up appropriately, I'm going to have a contact force between that rock and everything else. My lead ball, I guess. We're going to see how much force does it generate when it runs into things. More importantly, when does it run into things? So we'll see this pop up here as soon as that's done. As soon as that's done. And it pops up this little plot for you. And so if you are working with one of these, one thing I want you to know is that this plot it's parametric like everything else in SolidWorks. So as you're dragging that around, you can see that spikes right at the moment it hits our teeter-totter. That's actually the highest force that our little ball of lead sees. Now, I would have a chance that if we were to do that also on the diver, we'd have some pretty fun results. But I wanted to just show something else instead of showing that again. I wanted to show that you can go right down here and do results. You can edit them. You can bring it. You can show it. And I wanted to change that to, what did I do? Trace path, right? All right, and one more time, he goes flying out. Can't see it enough, but what you can see enough of is, there we go, that's what I'm looking for. So if that was the displacement of in the direction of X of our diver as this study progresses, you can see how it gets further and further away as you go. Maybe this one's kind of elementary. You didn't really need to go through that, but there are other variations that might be useful for you. Now, what I did do, and I think is kind of fun, and it produced a really neat result, is the trace path. And the trace path can show you visually, like it's kind of like what it sounds like if it has a tracer. But it's like a 2D line. I'm throwing in some extra views. I'm trying to be fancy. We can go just a little bit further up ahead. Okay, here's our trace path. And I select his head. I want to see where his head moves in relationship to, we'll say the edge of the diving board plank there. It does need to be like a body and an edge, otherwise it can't calculate it if you have too many limitations on your degrees of freedom. But now we've got it all set up, and it should show a nice little path as to what's actually happening between our diver and the diving board as we rotate about, and he dives off into the abyss of nothingness. It stops based on your time. If you put the time up, it'll just keep going. Yeah. Yep, exactly. All right, and now for the main event of any medieval fair, the gratuitous jousting match. This is a little bit more visual than anything else. There's a ton more. I cannot emphasize this enough. There's a ton more in the reports that you can generate if you've got the motion analysis capabilities. You can really take that a long way, and I'm going to tie this into something a little bit later, but it can take that a long way into pre-prototyping or requesting capital funds. When they have some information to go on and they say, oh, you've really done your homework, it can make things go a lot smoother. Now, for our jousting contest here, let's say I've gone over adding gravity and adding rotation, and we're just going to add a plain old force to these guys. There's a lot more you could do to a horse, of course, but as adding a force, I think, was the cleanest way to do this. We also are going to hopefully unhorse somebody, so we want to make sure that we've got some gravity so that the rider doesn't just fly off into oblivion until we stop the video, right? We'll get that going. And so we left off with our diver, and we're going to move on over to our jousters. Before anything else, who's going to win, black or blue? Black knight. Black. 2 for the black knight, 4 for the black knight, blue. Everybody else? All right. We'll see. Remember your choice. I won't. Okay, I did want to show that SolidWorks can render the environment that you have set. There you go. So right here in your motion analysis. So if you wanted to give it a different background, I just have that landscape that I generated for our background. I changed my settings to be realistic view, added shadows, turned off the hard edges. That looks pretty good. Let's do some motion analysis. Got to switch my configuration for the Black Knight, of course, so we can tell them apart. And what I did is in here, I'd have this set up already. I didn't want to bore you with it, but there's your force. I'm going to show you pretty much how this works. You pick a reference, you pick a direction, you define a force. It's that simple, and it will move it for you. You can apply different coefficient of frictions if you want, and that's going to have a result in the motion analysis level. But if you just want to get some motion in your video, it's the easiest way to go about it. And I played around with the values. 150 foot-pounds seemed pretty good for what we're moving today. This is also defining the contact sets. Obviously, that's going to be very important in this situation. So we've got also 240 frames a second. This one's going to take a second to render. I'll fast forward through it. But I needed that kind of resolution in order for this to actually work, at least pretty close to what I think would happen in real life. I did want to mention this guy right here, use precise contact. I have that at 1/100,000th. That's pretty tiny. Again, that adds to your rendering time, but that's the kind of resolution that it can actually calculate in. Okay, we're moving kind of slow because it is going to take a little while to render. We have I've set up some keys in the video sections, or excuse me, the orientation section to make sure we have a good look at the contact point. And you can't really see it. I tried my best, but it looks as though the Black Knight's lance hits first, sending our Blue Knight flying off into the sand, looking like there's absolutely nothing wrong. Like he didn't just get knocked off a horse, and the Black Knight rides off into the sunset. Now this is going to take a little while to finish rendering, and this is maybe one of the things that I can say, don't have a situation, if you can avoid it, where you've got a solid mass, even if you have the contact set, that can move through a thin body like this, because it ends up no clipping into the back rooms. That one's for your youngins. It ends up kind of moving through moving through and trying to solve to two different sides of the body. If I had made that sand thicker, this probably wouldn't be getting so hung up right here. But I'll let this chug for just a second. I did bring up the computer statistics, and one thing I wanted to point out is that this isn't necessarily the world's greatest computer, but it isn't a shabby computer either, and it's still only operating 7 or 8 cores. I couldn't quite tell for sure. That is something that's intrinsic to SolidWorks. If you're ever looking at buying another computer for SolidWorks, unless you're going to be multitasking doing something else while you're doing SolidWorks stuff, fewer cores at a higher speed is probably better. So if you find something with 18 cores running at 5.2 gigahertz, probably going to do a little bit better than 24 running at 4.8. There's all kinds of considerations to take into that, but I did want to point it out for our motion analysis that applies here as well. Now our knight is almost at the edge of the sand, and you'll see that once he is floating off into the sky in a completely unrealistic manner, it goes pretty quick and pretty smooth. But we're going to go ahead, and now that that's all calculated, it should be quick to save the video, right? So we'll go ahead and switch it up to an MP4, make sure I have a good location. And I made a mistake here, and you'll see what I did. So I wanted to up that to 32 frames a second, but I left it at 3. And it's asking me if I want to overwrite, and that's how it looks at 3 frames per second. It's a little bit more exciting than watching the solver actually solve it. But we're going to go back to something realistic here. 32 frames a second looks good on most screens. So this is what I would want to maybe export to somebody else if they had a marketing document, or if we anything where they're going to have a little bit higher resolution, maybe for a website or something like that. It still takes a little bit to solve it. Obviously not as long as the original solution, and it doesn't hold up or get jittery when it's kind of clipping through that thin sand there. And we've got a nice little video, which I'll show you the results. It's almost as fun to watch as the diver bouncing out of the pool. Okay, now what do you do with these? What comes next when it comes to any of these videos? Well, if you have Visualize Pro, that's kind of its own use case where you can take those animations, import it into Visualize Pro, you can render them with you with photorealism. Not as easy as it sounds, but it absolutely is possible. I saw somebody very early on in my time with Swift. I had no idea what they were doing. I said, okay, well, I'm just going to take my plant floor layout simulation. I'm going to run it through Visualize Pro, and he had like basically a working factory in completely photorealistic rendering. It looked like almost like somebody had walked through a factory with a video camera and had mannequins doing their thing and things moving all down the lines. It was too perfect though. There's nothing, there's no trash. It wasn't dirty. You could tell. That's the only reason you could tell it wasn't a real video. Now, design validation, I think, is another big one for videos. It might seem like you're playing. It might seem like, oh, this is just, you know, Billy over here, Jester Tom over there at his computer playing around with this video. But when you are taking time to get intimate with a model and explore all of the ins and outs and how things work together and setting up your motion mates, that can help you find all kinds of things and stop issues before they become problems on the production floor. So also is a great way to go through clear communication processes. If you have, let's just say you have a marketing meeting and you can show a picture, and picture says 1,000 words, which is certainly more than a blueprint, especially if your marketing team can't read a blueprint. How many pictures were in that video that I just did? 32 frames a second for, there's 100 photos for you right there. It gives a really clear, very quick way of communicating your engineering intent without necessarily getting too much into engineering. And also training documents, assembly instructions, service guides, presentations, installation manuals. There's all kinds of uses for this, especially since even installation manuals aren't on paper anymore. You got somebody out in the field, this toolbox and a smartphone. He's going to want to see the videos of how that goes together. All of us who put together something from IKEA would have loved a video of how it goes together. So these are just a few examples, I think, of where we can take this, even though there's a lot more. Oh, I'm doing fine on time. Okay. Well, that's good, because as I mentioned before, I definitely have something here for everybody. This isn't necessarily, this isn't Swift saying this is something for free. This is SolidWorks gave everybody this functionality, and that is the Simulation Express. And if you've ever used some of the other programs out there, you know that they have a built-in, we call it a first pass FEA, very basic, but still very informative kind of simulation built right into their programs. And SolidWorks has had this only for serial number managed installations, but they've had it for a while. And people don't really know about it and don't really use it. Now it's available to everybody if you upgrade to SolidWorks 2026. Not a tier, but you're just using the product tier 2026. It's in all versions, including 3D Experience, and I think network licenses, as far as I know. All right, so I just said all that. All right, so I do want to talk not just about that the add-in exists, but I actually want to go over some of the main functionalities. And since it is a free thing that they just kind of tossed in, it does have some limitations. But if you know how to work with those limitations, you can get a lot out of this add-in. Even if you're not necessarily a structural or mechanical engineer, there's still cool insights to be found with this. Now, one thing that Swift does do is we have a weekly coaching call. And at Swift Keep, you saw there is a cathedral-y looking portion in there. I asked our attendees to make me an ugly CAD sweater, and I would put it on the mannequin and kind of have a mock concert and see if we could break the stage that I built for this concert. Now, to be fair, I know people are busy, didn't get as many entrances as I wanted, so I made the stage out of balsa wood. We'll see if we were able to break it. We're going to start first with just a part, and in that part we're going to talk about the use of the split face feature in SolidWorks, and that will give us those boundary conditions for forces. You don't need to really have a huge background in engineering, but if you have a load that's spread out over an entire beam, you're going to have a different result than if you have a concentrated load in the center of a beam. We'll get into that here real quick. So moving on to our cathedral, we have our concert goers inside there. So let's go ahead and see what they're up to. We have Jester Tom directing the choir. I don't know what he's thinking, but he's trying to get them to sing a SolidWorks song. And it looks like maybe that stage might be holding up okay. Well, we don't need the whole cathedral, so let's get out of there. And we're just looking at this portion of it. In fact, let's get Jester Tom out of there. Okay, thank you. Now, it would be great if we could go right here and run the simulation right from this level of the software, but you're going to see a warning. So go up here, Tools, Express Products, Simulation Express. If you have 3D Experience, SolidWorks, now called SolidWorks Design, named user license, it will say Simulation Express doesn't support assemblies. Okay, fine. I get it. Let's go and look at a board. Let's just look at one plank, and let's see can we glean anything from this one plank? So into our Simulation Express, sorry about the errors. I was playing with this before, but look over on the right-hand side. It kind of guides you right through everything that you need to do. It calls the task pane. It wants you to set your fixtures. Now, yes, my fixtures in real life are kind of up and down, close to the ends, but not on the ends. But without making any other changes to the model, this is going to get us pretty close. Just an idea of what this force is going to do to balsa wood. And that's me showing, hey, this is spreading across the entire board, and we're going to just select 75 newtons for an androgynous medieval knight mannequin type thing. Why not? And for some reason, it makes me go through and reapply material, go back and apply balsa wood again. I don't know if that's a little quirk or if I did something wrong. I have not encountered that before this model, but also I hadn't used this product or this version in a while. Now, much like any other simulation, it does triangulate. And so you saw me drag that slider bar back a little bit in respect for your time. I don't want this to take too long, so we reduced the number of triangles, and it gives us a preview. And as long as this preview is acting pretty much like you would expect, you're in a good position to move forward. Again, going back to if you were to request some kind of destructive testing from a model shop back in the day, you would have to write out your engineering calculations as to what you thought that deflection might be, sketch out that picture that it's animating for you, and now it just kind of does it for you. And you can take this even in this basic level and have an idea of what it's going to do. Now keep in mind, the deformation scale up here is 10. So that's moving 10 times further than what you would actually expect to see in real life. But we get a nice stress strain plot out of this. And what this is showing, and I want to caution this, we're not teaching FEA interpretation, but what this is showing is where concentration or where deformation is high, not that red equals bad. Certainly shows you where something is higher or lower, but it doesn't necessarily mean that if there's a speck of red, that something might fail. If you're getting into that level of analysis, certainly look into training on how to read an FEA or a factor of safety plot. And a factor of safety is simply what it sounds like. At what point is this going to break? Again, it got cut off just a little bit, so you found a factor of safety in your design of 9 point something. So I set it to 10. And it looked like we're just going to let this keep rolling. Now I am assigning a circle here in the part, and I want to make sure that that circle isn't grabbing on to any references. I did that by pressing F3. So if you ever have a situation like if you're working with splines and they don't want to grab onto a point, and you press F3, you can create your spline and then you can just put it in wherever you want without any of those external references. Just make sure you press F3 again to bring it back. But we create a split face. Now we have a periodic face that we can run our simulation with. That way we can see where that concentrated stress is actually going to affect things. I'll go ahead and run through this real quick. Now you see the force that it's applying is only located in that split face that I created instead of being the entire plank. That is going to affect the outcome. Okay, we'll let this roll. Got to change that material again. But I'm sticking with balsa wood because I'm stubborn like that. And to be honest, the reason I'm choosing balsa isn't for its strength properties, it's because it has all the properties pre-filled out for you. And I didn't feel like making a custom property for a different type of wood with all that information. So balsa it was. However, to head off any possible questions, if you do have custom property or custom materials, it will respect those as well. You just have to make sure you have all the properties filled out appropriately. Okay, now looking back at this, our stresses are slightly different. And we see our deformation scale is completely different. It's only, the scale is smaller, but the image has moved the same. That means that the wood is actually seeing higher levels of stress because it doesn't have to scale it up as much in order to make it move that far. Okay, so that's about all we can glean out of this for a single part. And that, using the split face in order to get more information out of it than you would have been able to with the software originally, makes it so much more valuable. If you wanted to, you could put a split face on the bottom as well for where the vertical supports intersect the board. Or if you added gussets, make split face for them. And then you start fixing those during the add fixture portion, and you get better and better results. Now, this is cool for a beam. We actually can go to a textbook or actually several manufacturing books and look up this value of how much a 1/2-inch beam of balsa wood at certain dimensions can support. We want to look at the whole assembly. But before, it said when we tried to run an assembly that Simulation Express doesn't work with that. So let's find a way to get around the assembly limitation, and we're going to auto-generate a report. All right, one more time, back to Swift Cathedral. We will go ahead and open up that, we'll go ahead and open up the ye olde stage. I made another configuration for this, gets rid of all of them, but you'll see that I already went through and put split lines in. However, a couple of them are on the bottom. Well, that's going to make things an issue, isn't it? If we have some forces going up and some forces going down, we can get around that too. So, okay, well, we can't do this in an assembly. We already knew that. Instead, I'm going to do a save as part. Anybody save an assembly as a part before? Most of you? If you haven't done it before, super handy. Watch out for this guy right here. Make sure you're getting all your components, especially in this kind of application. Right there, it was just warning me too that I'm saving over because I might have done this a time or two in preparation. I'm going to go ahead and open up my part. So I changed my filter to part, and I believe that was my most recent one right there. And now see, we don't have a bunch of parts in our feature tree. These are a bunch of bodies. So it's a part though. It says solid part right at the top. It should be good, right? Not so much. It's currently, it only supports one body at a time. So I'll let it, let me catch up with the video for just a second. If you have a multi-body part, you'll see the solid bodies folder appear, and in it, it will list any of your bodies. So if you had one sketch that had 3 circles and you extrude 3 cylinders, it would list 3 bodies right here for you. And there's some pretty cool stuff that you can do with this. It's basically going back to Boolean operations, and you're thinking it's 2025. Why are we talking about Boolean CAD at this day and age? This is an exact reason right here, because if I select all these bodies, I know that all these bodies are planar to one another because I designed it that way. And so I'm just doing a shift select to get them all, right click, and right here's our combine command. Now, like I said, Boolean operations, add, subtract, or common. So if you think about like a Venn diagram, common would only be those 2 crescents in the middle. And we're going to go ahead and change it to balsa, hit close. Now it is one body. It is a part. We go to Simulation Express and we're in. It is on like Flynn. So now fast forward through this just a little bit, but I assign a fixture to all those feet on the bottom. If you had more advanced CAD, yes, we could assign a coefficient of friction to come up with sliding, etc. But that's not really what this kind of software is for. This software is to give you an idea of what the design might do, maybe show you some hot spots. But right now I'm assigning those forces. And you say, Tom, you must be a jester if we're going to try to simulate it this way. That's not going to work. Well, it might. It would give us some really funky results. But using this selected direction option and a plane gives it one face to direct to. And then changing our force, of course, 75 newtons per item, reversing the direction. Yeah, those 2 on the left side are going to be pulling instead of pushing, but we're going to get pretty close to the results that we'll want with that. Go ahead and click next. I didn't change my mesh settings. I just ran the simulation and it's showing us about where that flex is happening. Now again, von Mises stress, I'm not going to get into too much, but this more or less aligns with what we expect after looking at the single plane. It's going to be a little off because these wouldn't be joined like this in real life, so they wouldn't have that support of the other B about them. but it's close enough to give us an idea of what's going to happen. And now I'm looking at the factor of safety. So the factor of safety plot that I used before was 10. Using it in an assembly, yeah, we'll see some hot spots showing up, but it's not really telling us a whole lot. And that's 10 times 75 kilograms at each one of those, by the way. So that's enough force to, well, that's more if I had eaten a feast like we had out there today. And so I'm going to bump it to 20 so we can really see where we're going to start to see some problem spots. And just kind of remember what this image looks like, that red and blue. We do something cool with it here in just a moment. And that is, I was yapping. I want to make sure you see this one. Generate report. Okay, so it's asking us now, what do you want us to generate? Well, I just threw in some stuff real quick. You can get as complicated as me to fill out all your company information. Maybe if you're consulting, and it's good that you keep track of who you are doing these for. There's a braid that includes all that for you. Let's now run through this, and it's going to generate a bunch of videos. And I will warn you, it will take hold of your GPU stack and cause all kinds of issues. You're trying to record this with the screen recorder. Don't know why it gave me such headaches. But once I finally got through it, it's going to do a whole bunch of work for me that I normally would have had to do in order to generate a report prior to, said before, capital request or someone's having a destructive test set up. They want to see these types of reports beforehand. All set up, all here for me, all with the information about how much force I applied, what my mesh looked like, what my settings were. And I think probably the coolest thing here, I'm going to zoom in right on this, is that our factor of safety here is 20. That's what we looked at last. That's why I said, remember that red and blue pattern. And hold that right into the report because I thought it was important. And it grabbed that for me. Now, I just want to thank you very much for joining me through all of that. SwiftGeek has been really fun. It's been a really neat way for us to engage with our customers, but also for me to learn about SolidWorks, right? It's kind of fun to design medieval things without having any ramifications if those beams break. That's all right, my legs die, I don't care. But as a quick thank you from us at Swift, we would like to invite you to further your SolidWorks education by coming to one of these classes or coming to however many classes we have in 90 days. They are hosted once a week on Wednesdays at 3:30. And if you go ahead and scan that QR code, it's going to alert me and send you an invite. And we are asking for entertainment. This isn't a way for us to make money off of you. This is something that we would really like to see everybody have access to in order to just kind of grow and learn how to use the software better, whether that's better based on what we tell you or whether that's better based on what you tell us you want. It's definitely a back and forth there. So we would be really happy if you join us in that course. So thank you very much. I do also want to say thank you to everyone who worked so hard to make this event a reality. I know a lot of people put a lot into it. So if you see anybody who did have anything to do with setting this up today, make sure you give them a big thank you because this is great. Otherwise, information up here for contact. You are welcome to contact me after this, and I hope to hear from you. And have a great day.